Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Radicals. Question 8. Solve a radical equation algebraically. Inbox me at memedicine@gmail.com to purchase complete Cram sessions. Review question 8. Solve algebraically for x. Radical 3x plus 1 is equivalent to x. Definitely press pause if you need to, and I'll give you a moment to think. All right, so to solve this radical equation algebraically, we're going to have to isolate the radical term, and we can do that by subtracting 1 from the left-hand side and the right-hand side of the equation, okay? And now what we're going to have to do is get rid of the radical. And we can undo this by squaring, because if you recall, the index that's usually not written on a radical is 2. Okay, so this is the second root or the square root. All right, so to undo a root, all we have to do is raise the expression to the exact same exponent. All right. And so remember, whatever we do to the left-hand side of the equation, we also have to do to the right-hand side. Again, squaring on both sides is going to get rid of the root. So exponents and roots are inverse operations that cancel each other out, okay? But just keep in mind that squaring, squaring in this way will only cancel out the root. But this type of squaring can give rise to a phenomenon or a glitch in algebra called an extraneous root, because if you recall, let's say we substitute 2 for x, and that's in fact valid. Well, -2 could also be a valid answer as well, and you'll see why this is in a little bit, okay? So now we're going to just solve algebraically. On the left-hand side, we get 3x plus 1 because we got rid of the radical. And if we FOIL this term, if we are to basically multiply the first two terms, we're going to get x squared. And if we multiply the second, pretend there's another x minus 1 written here, like so. So what I'm doing right now is FOILing, okay? And so when we multiply the first two terms, we get x squared. Then when we multiply the outside terms, we get negative x. Multiply the inside terms, we also get negative x. And then when we multiply the last terms, we get positive 1. Again, this is the FOIL distributive multiplication method for those of you who have never heard of it. The acronym FOIL stands for multiplication of the first terms, multiplication of the outside terms, multiplication of the inside terms, and multiplication of the last terms, okay? All right, so let's continue solving. Now we're basically going to combine and get rid of some terms. If we combine these two x terms, we are going to end up with 2x, but notice that there's a positive 1 on the right-hand side as well on the left-hand, as well as on the left-hand side. So those two terms can cancel out, and we end up with 3x is equivalent to x squared plus 2x. We could have also went ahead and combined all the x terms, but I don't want to jump too much steps for those of you who are novices, and you know, sometimes it's not good to do everything in one complete step, just to keep yourself organized to prevent incorrect solutions, okay? So now we can go ahead and combine all the x terms. If we bring 3x over to the right-hand side and then flip the entire equation, we end up with x squared minus 5x is equivalent to 0. Now what we can go ahead and do is factor out x, and we wind up with x times x minus 5 is equivalent to 0. And according to the zero product property, if we have two factors that yield a product of 0, one of the factors is equivalent to 0 or both. Here we're going to assume both are equivalent to 0. Therefore, x is equivalent to 0 or x is equivalent to 5, because if you were to isolate the second factor, setting it equal to 0 and bring 5 over to the right hand side, you would get positive 5, okay? But remember what I mentioned earlier about extraneous roots? Because we're squaring this term here, you know, there's like a hiccup somewhere in the magic of math that does possibly give rise to extraneous roots. So what you always want to do is check your roots or the solutions that make the equation equivalent to 0, okay? So we're going to check our first solution or our first root, x is equivalent to 0. And when we plug 0 back into the original equation, we get 3 times 0, so that's 0 plus 1. So radical 1 is 1, plus another 1 is 2. So does 2 equal 0? Nope. This is an extraneous root, so x is equivalent to 0 doesn't check. It's not a solution. Now let's check x is equivalent to 5. Well, when we plug 5 back into the original equation, original radical equation, we get 3 times 5, that's 15, plus 1 is 16. All right, so the square root of 16 is 4, plus 1 is 5, so that 5 is definitely equivalent to 5. Our solution checks, and the final answer is x is equivalent to 5. Thanks for tuning in. Good luck studying.